This video, we will finish about the shortest route implementation. Then we will moving forward to the cheapest route. So let's continue with the previous video. We didn't finish about the BFS shortest route function. So then you will see the most important thing, we will not return a queue anymore. We return a stack. So this stack, because when we first we push in, will push from the end node. So that's why when they pop out, you will see the route. They will start from the start node. But be careful, here is only the index. So that's why when you want to build out the route, you need to use the index to find the name of the index from the database. So that's why here we build up our result stack, declared that. We still have the to-do, that's the queue, to-do queue. So then the initialization, like earlier we said, before we have the isVisit equal to false, but now we need to add the pref need to be -1, the cost need to be 0. So then right, let's have our first, the original node, that's the isVisit equal to true. So we can push that into our queue, to-do queue. So that's our iteration on the recursive step. So while the to-do queue is not empty, right? So we just using the from one, that's our considerate. Remember earlier we said this one. This one is the node under the considerate. So that will pop from the queue. So we need to consider all the neighbor from this considerate node. So we need to use a constant iterator. So then we start from the beginning to the end. So if this neighbor not being visited, right, so then we just need to do what? We set the isVisit is true. But here we need to update. For this neighbor's pref will equal to the earlier our considerate node. So then the cost, be careful. You update the cost for the neighbor, right? You see, using the database, using the reference. So then you need to use the 1 because every age is only 1 cost. So you need to find the original cost from the considerate node I, then from database to get the cost. So then, right, so then you need to push to your to-do. So now here, no, not yet the results push. So you just need to do the to-do push. So then you push this neighbor into the to-do queue, right? So then continue, we will see here. So if this considered node is the end city, actually we finish. So that's why here we need to check. If this node is the end node, so then actually we need to pop out all the nodes from the queue. So that's why we won't come back to the while loop. So then here actually we break out that from our for loop. But actually we break out from the for loop because that will become empty. So then we finish. But of course, if this node is not end node, you see we just continue to our recursion step. But one thing is after we finish, right, you see all the nodes information being updated. And the end node, we already know that. So that's why here we need to push our end node to our result queue. And also one thing is because the first thing I push the end node, right? And also later I need to continue to come back. So that's why I have the index equal to the end node. If this index not equal to the original node, that's our start node. I just push. So then after I push, don't forget you need to go back. So that's why you need to do the index from the database to find there is pref node. So then this pref node will become the new index. So right, we just continue to check. We finish until they are original nodes. So if not, you see, you just continue to push the pref node into the result queue. So result stack. Then the last one, you push your original node into your result stack. So then you only return the result stack. But not finished yet. This one just the shortest route function, right? So that's why in your main function, right, the main function continue. Actually, that's all the same as before. You need to read and parsing your map, the txt file. You build up your database like before. But then after you finish your database build up, right? So actually our main function, we will ask the user about the star city. We will ask the user about the NCT. User only give you star city and NCT, but our job is we also need to find where is the star city index. So what is our NCT index? So that's why here the INJ, this I actually mean the star city index. Okay, so then here you see the J, that's the NCT index. So so that's why you notice index, right? So that's why you can call your BFS shortest function. You pass in your start node and end node index in the database. So then they will return you a stack. So you see again, that's only the stack, right? So it's not enough. We need to display the route. So to display the route, you just need to pop out all the nodes from the stack. But when we display the database name. So then after you finish, you will see here, they will display the route. So let's try, you see, you can run this program. Okay, so that's why you see, for example, we want to from San Francisco to San Diego. So now you have your shortest route. They will display start from the start node name. Then you do one by one to do the San Diego. So that's at the end, this one, after we got our stack. So that's how we display the route by one. So then finally we finish our shortest route. So you can take a break, but now I need to continue to talk about how we will build up our cheapest route. So when we try to find the cheapest route, that means actually we will add one more information into our database. So then here, remember, since you want to find the cheapest route, earlier our shortest route, we don't have weight. So each link, their weight only 1. But now when we try to build the cheapest route, we need to consider the distance now. So I know the feel like you say distance, you should say shortest, right? But just consider the cheapest, our cost is the distance. So maybe you don't think about this one's distance. We just think about this number is the cost. So that's cost for each link. So then, so when we read from the link cost, but how should we update our database? So be careful. You see this link, the cost is from the node I to J, right? You have your from node to the end node. I have the cost. So that's why here you will see here is our new node. I still have my name. I still need the proof and the cost to find the route and calculate the cheapest cost. I still have is visited or not. But here actually those link cost, they are at neighbors. Right. So that's why you see I have the Eureka. But Eureka maybe go to Coos Bay. Eureka go to Redding. So I have multiple neighbor, right? So besides I need to know the neighbor index, I also need to add the cost for this neighbor. So that's why now we will introduce you another template we call the pair template. The pair template actually they consist 2 data and also exactly 2 data. So that's what we call the pair template. They have exactly 2 attributes. So then here we need for our list is we need to have the first int for the index to the neighbor. Then I need the cost for the neighbor cost. So if I say this pair object is called X, right? So then here you see we only have a data type, but also they already have name. If I have an pair object called X, so your X dot first mean this value you refer to. So this X second mean this value you refer to. So that's why here if we make our neighbor become like this, right? So right, you see here, now our list become pair, int, and double, right? Right, so then when we consider any node, their neighbor, that's a list, right? Remember, we always need to use the iterator. But before our iterator only is the integer. But now here, our iterator, the it, will become this pair object. So that's why later we still need to use the iterator a lot. But now since our node, neighbor list become a pair. So that's why here when we do the iterator for the database neighbor begin to the end. So this it actually refers to a pair object. So this it, you using the arrow to point to the first, that means you refer to the neighbor's index. But if you use this it second, that means you try to get the cost. So then here, if you want to get the neighbor nodes from the database, right? So that's why you need to use the index and using the database vector. So that's our new database. So right, so after you have your new database, right? So in our main function, how we will read this text file, they will change a little bit as well. So right, so here we need to add get line for the cost for the second line. Before we ignore this one. So after you get the cost, right? So whenever we try to update our from node and end node information, so here we need to add this one change. So that's why whenever we try to build up the neighbor information, so that's have our pair int double h first. So then you see when we want to update the two node in the neighbor, so you see here, that's the from node neighbor. So you see your h, the first will be the two node. So the second still is the cost. We do A to F because we read as a string. So then you need to push the H object into the database. So then again, using this one, your first need to change become the from node because we need to update the two nodes database for the neighbor node. So that's how you will change for your database reading. But here I also give you the sample code. But one thing is really how you will update your cheapest route. So that's why here, so that's continue like earlier we show you the shortest route. So those shortest route, remember, you see we do the level 1 neighbor, level 2 neighbor. So when we find the end node, we just finish. But now it's different now because now at older time, we have the link with the different weight. So that's why all the time we need to update again about our cost. And also, did you remember before we said if this node being visited, I don't need to revisit again. But now, no, actually all the routes we need to go over one by one until we finish. Because one thing is all your age, they have different cost. So that's why all the time, for example, earlier when I got this point, for example, I have the start node from here, right? So this node is 10 plus 1 become 11. But then later on, if these two nodes, they are the same end node. So then you will see here if there are only 1 and 1, this one becomes shorter. So that's why even this node I've been visited before, I still need to update their cost. So that's why for the